Hello everyone, welcome to our session. Today we are going to continue our discussions on the solvable groups of trigonometric integrals. But this time we are going to focus on group 2. So group 2 is integrals of the form integral of tangent u to the m times secant u to the n du, and we have tangent u to the m du, or integral of secant u to the n du. Okay, so where m and n or where m and or n are positive integers. Okay, so like in group 1, we also have cases. So here we have case 1 for group 2. So when m is odd, then the rule here is to factor out secant u, tangent u, du. Okay, so just factor out secant u, tangent u, du. So when m is odd, and change the remaining tangent into secant using this trigonometric identity, tangent squared u equal to secant squared u minus 1. Okay, so for example, if you're given something like this, integral of tangent x cubed times secant x to the fourth power dx. Now, if you look at the exponent of tangent, which is where m is exponent of tangent, so here we have m is equal to 3. So m is odd. In this case, m is odd. So the rule here is factor out secant u, tangent u, du. Okay, so I will show you the step-by-step solution for this problem. So our given integral function is integral of tangent x cube then times secant x to the fourth power dx. Okay, so as the rule says, when m is odd, so as you can see here, our m is odd, right? So case 1, so case 1, m is odd. So what we're going to do is, so case 1, m is odd. So when m is odd, we have to factor out secant u, tangent u, du. Okay, then after that we have to change. So we have to change, what to change? We have to change tangent to secant. So change tangent to secant. Okay, so those are the things that we need to remember. So to change tangent to secant, we need to use the identity, this trigonometric identity, which is tangent u squared equal to secant u squared minus 1. Okay, so we are going to use that identity. So to continue, okay, so I'll put the equal sign here. So what we're going to do is to break, okay, so we break this tangent cube into tangent cube x into tangent squared x and tangent x. So we can rewrite this as tangent squared x times tangent x. Okay? And we can break also secant to the fourth, because the rule here is you have to factor out secant u tangent u du. So here we break tangent cube into tangent squared x so that we can produce tangent x. Here we also have to break this into two factors so that we can produce a factor that is secant. Then combined with this tangent, then we can factor that them together. So this one can be written as secant cube x times secant x dx. Okay? Then combining this tangent x and also secant x and this one dx, so that we can factor out this following that rule. Okay, so rewriting, so we can rewrite this as integral of tangent squared x multiplied by secant cube x then times tangent x, or we can interchange. You can write secant before tangent. So we can write this first, secant x, then write tangent x, then dx, just to make sure that we have this secant x tangent x together, so that we can do this rule here. We have to factor out secant u tangent u du. Okay, then after that we have to change the remaining tangent to secant. So we have here tangent squared, we have to change that into secant so that everything will be in terms of secant. So we can write this as integral of, so the tangent squared x, we have to rewrite that as, or the write the equivalent or the identity. So secant squared x minus 1. Alright, and then multiplied by secant cube x, then secant x secant x tangent x dx. Then after that we have to distribute this into each of this term. So meaning the whole thing here, we have to multiply it here and also this one. Then this should put this integral sign on each term. So when you multiply this by the first term, so we have the integral of, So this becomes secant to the fifth, because squared, then you have cube here, or 3, you have 2 and 3, so 2 plus 3 is 5, then x, and of course you have to include this one, secant x tangent x dx, so that is our first term. Then we have minus, okay, so this is minus, so minus, then integral, so you just distribute this integral sign also, secant cube x secant x tangent x dx. Okay? Then, if you look at this part here, class, secant x tangent x dx. Are you familiar with that one? If we recall from our differential calculus, if you have, in differential calculus, if you have derivative of secant u with respect to x, or derivative secant u with respect to u, this is equal to secant u tangent u. Secant u times tangent u. Okay? Now if you are going to multiply both sides by du, so you have derivative of, or the differential of secant u is equal to secant u times tangent u du. Okay? So if you look at the terms here, so you have this factors class, secant x tangent x dx, and that is, if you compare it to the formula, so this is the du, no? The du of whatever is our u here. So if you, for example, if you let n, in this case n is equal to 5, okay, for the first term, and then if you let u equal to secant x, then our du, we'll just go directly here. So du, if you take the derivative of u with respect to x, so you have du over dx. So du over dx is simply equal to secant x tangent x, right? Now if you're going to cross multiply dx, or multiply both sides by dx, so you have du equal to secant x tangent x dx. Okay? Now, if you look at the other term, so same, no? So you have n here, but n here is equal to 3. But again, this part here is just the same as this, right? And that is exactly our du. So here we have n equal to 3, our u is the same, that is secant x also. Then I'll just write directly du. Our du is equal to secant x tangent x dx. Okay? So, substituting, so this becomes integral of, we let u equal to secant x, or secant x equal to u, so therefore this is integral of u to the n. Our n is equal to 5. Okay? Then this one, secant u tangent u, or secant x tangent x dx, that is just equal to du. Secant x tangent x, that one, which is equal to du. So you can write this as du, or you replace this by du. Okay? Then minus. So this part here, same. No? We have integral of, that is also u. Our secant x, we let that be equal to u. So u to the n, our n is equal to 3. Then this one also is just equal to du. Right? So this one is just equal to du. So substituting, so times du. Okay, so if you look at the result, so that follows the form of power, no? Power formula. So we can rewrite this as u to the 6 over 6, then minus, this is u to the 4th divided by 4, then plus c. Right? Then substituting the value of u. So we have u, which is secant x. Alright, so secant x raised to power 6 divided by 6. Then minus secant x to the power 4 divided by 4, then plus c. Right? So I will continue it here. So this is equal to, we can rewrite this as, this one, this part here can be written as 1 over 6. Then secant, you can also rewrite this as secant x to the 6, then minus 1/4 secant x to the 4th power, then plus c. Okay, so that's our final answer. Any question? Okay, so that's an example for case 1. So I'll give you another example, but in another case class. So that's all for this video. Thank you very much. Hope to see you again in the next video. Bye.